Hi all, have a good day. I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So in this lecture series, the next topic we will see is series and parallel connected sources. There are different types of sources, ideal and practical sources. So we will see each one in detail. So first we'll see what is a source. A source is nothing but a device which converts the mechanical, thermal or chemical or any form of energy into an electrical energy. So it is an active network element which is meant for generating the electrical energy. So the various types of sources that are available are voltage and current sources. So under voltage source, you have ideal and practical voltage source, and similarly in current source also you'll be having ideal and practical current sources. So first we'll see about voltage source. So voltage source is a device which generates an exact output voltage. In theory it does not change regardless of the load current. So ideal voltage source will be having zero internal resistance. But practically ideal voltage source is not possible and it cannot be obtained. So generally sources will be having some internal resistances, and so those type of sources are called as practical voltage sources. So because of this internal resistance, there will be definitely a voltage drop across the sources. So the terminal voltage will be less than the source. So this is the symbolic representation of ideal and practical voltage sources. So this represents an ideal voltage source and this represents a practical voltage source. The smaller the internal resistance of a voltage source, the more closer it is to an ideal source. Next one we'll see about the current source. So current source is nothing but in an electronic circuit that delivers or absorbs an electric current which is independent of the voltage across it. Here also you are having ideal and practical current sources. In ideal current source is a current source that supplies constant current to a circuit despite of any other conditions present in the circuit. So an ideal current source provides constant current with 100% efficiency. So this represents a symbolic representation of an ideal and practical current source. So ideal current source will be represented by a circle and practical current source will be represented by a rectangle. So in the ideal current source as shown here, the current will be constant throughout the voltage. Whatever may be the voltage, the current remains a constant. It does not depend on voltage. But in practical current source, as the voltage changes, there will be definitely a drop in the current. So instead of this ideal constant current, the current will get reduced because of the internal resistance as shown here. So this is the internal resistance of the practical source. An ideal voltage source also, you don't have any internal resistance. So the voltage remains a constant throughout, independent of the current or time. Whereas in a practical voltage source, you'll be having internal resistance, and so there will be definitely a voltage drop with respect to a current or time. So we'll see what happens when we connect several voltage sources together. So ideal voltage sources can be connected together in both parallel or series. Series voltages add together while parallel voltages have the same value. So here is a circuit which shows two voltage sources are connected in parallel, 10 volts and 10 volts. So in a parallel connection, the voltage will be the same throughout. So voltage at the point AB is also 10 volts. So ideal voltages can be connected in parallel provided they are the same voltage value. So when we connect voltage sources in series, it can be connected in two configurations, series aiding configuration and series opposing configuration. In series aiding configuration, the two voltage sources are added together to get the resultant voltage, and in series opposing configuration, the two voltage sources are subtracted to get the resultant voltage. So this is a circuit which represents the series aiding and series opposing configurations. The first one represents the series aiding configuration where these symbols are plus minus and plus minus. So these are series aiding. So 5 plus 3 will give you a total resultant voltage of 8 volts. If you see here, this is 5 plus 5 is connected in plus to minus, and here the sign is minus to plus. So this is series opposing voltage sources. So here my 5 minus 3 will give you 2. Similarly here also it is plus minus, but if you see here the voltage value is minus 3. So 5 plus minus 3, so it will be giving 5 minus 3 is equal to 2 volts. So this is also an example for series aiding and series opposing. So if you see here, current flows from minus to plus, and again here it goes from minus to plus. The direction is the same. So you'll be adding both 10 plus 5 in order to get the 15 volts in series aiding voltages. Whereas here if you see, here current flows from minus to plus. Here direction is like this. So both are opposing directions. So the opposing we have to put 10 minus 5, which is equal to 5 volts. Next one is current sources in series. The current sources normally it's not allowed to be connected in series because it will produce some unknown factors in the circuit analysis, which is not good for circuits. Another reason is it's not allowed for circuit analysis techniques because they may not supply the same current in the same direction. So connecting two or more current sources in parallel is equal to one current source whose total current output is given as an algebraic addition of the individual sum source currents. So current sources cannot be connected in series, it can be connected only in parallel. So here also again you have two configurations, parallel aiding configuration, parallel opposing configuration. In parallel aiding configuration, the two currents are added to get the resultant current, and in opposing configuration, the two currents are subtracted to get the resultant current. So this is a parallel aiding configuration. So here if you see I1 and I2 are flowing in the same direction. So at this point I is equal to I1 plus I2. So 5 plus 5, which is equal to 10 amps. So if you see here, the current direction is different. It is opposing, right? So 5 at this point, this is entering, this is leaving. So 5 minus 5 is equal to 0. Similarly here also 5 minus 3 is equal to 2 amps. So this is parallel opposing configuration. So here the directions are opposing. Hope you understood the ideal and practical voltage and current sources. What happens when they are connected in series? What happens they are connected in parallel? Let us take up some assessment questions. So in case of an ideal current source, they have the options are zero internal resistance, low value of voltage, large value of current, and infinite internal resistance. Yes, ideal current sources have infinite internal resistance, whereas ideal voltage sources have zero internal resistance. A practical current source can also be represented as the options are a resistance in parallel with an ideal voltage source, a resistance in parallel with an ideal current source, a resistance in series with an ideal current source, and none of the above. So practical current source, as we saw in the diagram, it is represented by a resistance in parallel with the ideal current source. The next question is, a practical voltage source can also be represented as a resistance in series with an ideal current source, a resistance in series with an ideal voltage source, a resistance in parallel with an ideal voltage source, none of the mentioned. Yes, as we saw in the diagram again, a practical voltage source is represented by a resistance in series with an ideal voltage source. Thank you for watching this video.